Okay, so what does that really mean? Equal distance from a line and a point. The line called the directrix and the point called the focus. Okay, well, that's what we're about to explain. Okay. Take any point in the universe. Okay, so pick a point in the universe. And then draw yourself a line. Any old line you want, really. Okay? You could do this on your own paper right now. You could just put a dot and a line. Here, let's try our own. We'll get some blank space over here. Okay? Draw any line you want and a dot. Yeah. That's never going to get old. That blush out. That's never going to get old. Okay? Maybe, but not anytime soon. Okay, so any line you want on your paper and a dot. It does not matter how far it is away from there, although that will change how the parabola looks. Okay? Halfway in between, put a dot. Halfway in between your dot and your line. And we're going to label that the vertex. Okay? Notice that the distance from here to here is the same as the distance from here to here. That has to be one of the points on the parabola. Because the distance from the focus, which was your original point, to the vertex is the same distance as from the vertex to the directrix. Just remember, directrixes are not just for kids. Okay, good. I'm going to pick another point, which is on my parabola, and I'll tell you, before you draw this point, I want you to understand why I'm drawing it where I am, and then you're going to have to do it on yours, because yours might be slightly different than mine. So, my second point is going to be there. Now, here's why. Because the distance to that point is the same as the distance to the directrix. Basically, I made a square, folks. You see that? Okay. Now, go make another one on the other side.
Yeah, it is.
Okay. Well, you're the one that decided how big the parabola was going to be. Okay? That's right, I did. I wanted yours to be different than the person next to you. Okay? I'm going to pick another point right about here. And another point right about here. Because the distance to the focus is the same as the distance to the directrix. The distance... So the purple dotted parts I'm trying to draw in there are identical. Now, don't try to say, well, Mr. Staley, if you go from, if you're choosing the first one that you did versus the second one that you did, the distances can't be the same. You're right. I understand what you're getting at. But what we're saying is in the world of geometry, this distance and this distance are identical. This distance and this distance are identical. This distance and this distance, maybe I should use double hash marks, triple hash marks. Yes. Yes. The vertex. Yeah. Okay. Well, nice to meet you, but it's kind of a weird name for your parents to give you, but now what you should see is that those points sit on the parabola that's my parabola. Okay? This particular shape is extremely important to every single person in this room. If you've ever driven or ridden in a car at night.
That's the headlight.
This is the shape of the back side of a headlight. If you did not have this shape on every single car in the back of the headlight, you would not be able to drive at night. Okay? No, you couldn't. Here's why. All right? Because you wouldn't be able to see anything. If you take a lamp, take off the lampshade and just have a lamp with a light bulb, and it shines out into the darkness, all the light goes in every direction. It is not focused. All right? Now, what happens on a headlight is that if you look inside your headlight, you'll see that right here at the focus is the light bulb. And that light bulb is sending light in all directions. But every single beam of light that hits that parabola, because of the shape of the parabola, gets ricocheted off in completely parallel lines. And because they go in parallel lines, you can see down the road. Same thing happens with every flashlight that you've ever had, too. If the light is not, if that parabolic shape wasn't there, folks, we would not be able to see very far, and we would not be able to drive very fast at night at all, without the possibility of running into many things or off the road. Running what? Or that. Yes. Okay. So, every parabola has a directrix, a vertex, a focus. What do you think we would call the focal axis? Where should I draw the focal axis? Does it go through the parabola, or does it run parallel to the parabola? Does it, what happens? It goes through it. There's your focal axis, folks. It goes through the focus. That's why they call it the focal axis. Now, I better be careful on this one, because they might define it as just a line segment that connects the focus to the directrix, but we'll have to look at it. There is something else that we, and I'll put a different color here. Whoops, that is horribly not straight. This is your focal width. Okay, from the focus to the outside edges. So when they refer to the focal width, that is from the focus to the outside edges, which is actually pretty easy to find, quite honestly. Yes, it is. So the two types of parabolas that we're going to focus on are the up and down variety, which is what you studied in Algebra 2, but now we're throwing in the left and right variety. Now, the one that you see that's the first one that I have listed here on the left side of the screen is a rotated one. We are not going to do rotated ones. Okay? You can. So we'll be doing the up and down or the left and right types. Now, where is the directrix in relationship to the parabola? Your choices are inside the parabola or outside the parabola. Where is the directrix? Inside or outside? Outside. Okay, the directrix is outside. The focus. Would you say that the focus is inside the parabola or outside? Inside. That's kind of important to know that the focus is inside and the directrix is outside. You know what else is going to be important? Pictures. You need to be able to graph. I keep telling you this. Graph it. That's right. Graph, 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 graph. That's all he ever says. Okay, now. We are the graph button. Okay, that's called your brain. All right, now. Okay, all right. I know, but it's somebody else do this for me. Okay, now, up or down, your equation is on the left. Please take a look at it. All right, now, where is the vertex? I notice that they haven't listed it out here. When you look at this equation, what is the vertex? Isn't the vertex HK? H is inside the parentheses with the X. Y is inside the parentheses with the K, with over the K over there. But when you switch to the left and right, you see how things kind of move? But H is still with X and K is still with Y. Yeah. Oh, the hyperbolas. Yes, yes. Oh, it's not green unless they figure this out. What if they wrote white text, but it was really green?
Oh my God.
Is it later or now? Later? 10, 12, building. See, Mrs. Summers. I don't know. Why now? Why can't it be lunch? All right.
I don't know. I
don't think so. Okay. Where was I? Nope, nope. No, that's the all the way to the front with the principal. Those are the big drug tests, and we are recording this, folks. Okay. What? Correct. All right, good question. When it opens left and right, is the vertex still HK? Amen, amen, amen. So you do need to realize, and you do need to pay attention to the fact that the squared term, you know, where the X and the Y are. Because that's going to determine which is your center. I'm sorry, which is your vertex. Noticeably missing from this list, there is no center. Okay? There is no center. Now, we could talk about the vertex, and that's kind of gives you the same idea. But if I ask you for the center of a parabola, folks, that's a trap. That's a trap, right? Exactly. No, I don't know what. Okay? I mean, I used to know one back in middle school, but then I lost touch with him. Okay.
Bless you.
Okay, that's right. That log just fell right, in half. Okay.
You're barely doing it. Red line.
Okay, now, stay with me. Try to stay with me. I know. Okay. Now, this distance, okay, when you look at this equation, you see this thing in here called 4p. It is the coefficient of the the linear term. Okay, coefficient of the linear term. It is the coefficient of the linear term. Please make note, folks, that parabolas have how many squared terms? One squared term. One squared term. Wow, it's bad looking. Sorry. One squared term. You know, so when we get quizzes or test questions, you know, where it says identify this particular conic and you can't do any algebra, you just have to look at it and go, hey, there's one squared term. That's a parabola. That's what you're going to do. I don't want you to look at one squared term and go, it's a circle. Okay, don't do that. All right, one squared term. So this 4p goes with what?
The focal width.
That is the focal width. So that is the distance across touching the edges through that focus, right? And how do I find the distance to? The distance to the vertex.
4 times the focal width.
Okay? So just 1p, that is the distance from focus to vertex. But if you recognize your definition, back in your picture, remember the picture that we drew in here a little while ago? So if I do this in, let's go orange. The distance from here to here is 1p. What's the distance from the vertex to the directrix? It is the same. What's the distance from edge to edge through the focus? 4p. Remember, that's what we talked about. So understand the picture of where you can use the 1p and the 4p version. That'll come up quite a bit. All right? Find the focus directrix and the focal width of this parabola. Ooh, that's a great idea. Draw a picture. Okay, now, they're trying to trick me here. Another way to write this would be this. This is more along the lines of the way that they're writing their okay, like they tried to trick me right from the get-go, but, you know, we saw it. We stopped them. What's my center? We don't have one. Good catch. Nice. What about that vertex? Okay. You need to write a song. It's all about the vertex. The vertex. No center. Yes, yes. I'm going to have to get a hold of Megan Trainor, see if she can redo that. I did. I don't know why. It just struck me. Okay. What's my vertex? Oh, man, this should be easy, folks. 0, 0, very good. Nothing's been added or subtracted to the y. Remember the h and the k? Oh, yes. Ooh, yes, it does look like an owl. Because if I go back up here and I look at the different forms of the equation, you know how it says, you know, you've got to do something, subtract or add before you square it. None of that has happened. There's no phase shift or vertical shift going on here. Whoa. This one is going to be either up or down. You can tell which way it opens, whether it's up or down. At least we know that. We got the up or down, which now we have to decide which one it is. I'm going to say the negative right there is going to pretty much answer your question. Ooh, this is a down opening. So we know that the vertex is right there. Anybody know what 4p is? The focal width? 4p. And if you go up here, it says the absolute value of 4p. And according to this, remember, it was in front of the non-squared term, the linear term. What's in front of the non-squared term? Ah, so what's the absolute value of -3? So the focal width is 3. What's p? What's 1p? If 4p is 3.
Why didn't you multiply the
Yeah.
by 4?
Okay, now I need these two things, and I'll show you why. Which one do I need first? Do I need the focal width first, or do I need the p-value first? Go back to my picture. Whoa. Which one of those do I need first? Do I need the p-value or the focal width 4p? I can't do the focal width 4p unless I know where the focus is, so I need p first. Thank you very much. Okay? We found it from the equation. We needed to find the focal width. We found it. Then we used it to find the distance to the focus, which is 3/4 of a unit. So I'm graphing this thing. And I come down 3/4 of a unit. So here's my vertex. Here's my focus. How far right and left do I go? Remember, we've got to use that focal width. How wide is it? How wide is it at that point through the focus? It is 3 units wide. 3 units wide. Yes, Miss Johnson? P is right there. That's the distance from the vertex to the focus. We did need to know that it was opening down so that we could know which way to go with the focus. How far right and how far left should I go so that my focal width is only 3 units? 1.5. I don't know, you were here the whole time. The distance all the way through there, folks, has to be 3. That's 4p. So we did need to know what 1p was so that we could find the focus, so that then we could say, okay, the width across that spot is the 4p, and we could graph. And yes, folks, I'm sketching this. I'm not plugging in a whole bunch of points. I just want to know the basic sketch of it. I want to know the vertex. I want to know which direction it opens. I want you to have the right focus and use the focal width to get me 2 more points that you could sketch. All right. Yes? Mitch Murphy. Okay, we took the p-value, which is 3/4 of a unit, and we went down 3/4 of a unit. Okay, so focus, we should call it focus pocus, because the p stands, I'm just trying to focus pocus. All right, so what's the coordinate of the focus? What? The vertex is 0, 0. 0 what? -3/4. Now, they also asked me for the directrix. I'm going to draw it in. And then I'm going to ask you for its equation. So here's my parabola. Here is 1, right? And here is my directrix. Watch it. Whoops, whoops, whoops. Now, how did I know how far to move up? Ah, that is P, which we know is 3/4 in this particular case. So now you can answer my question. What is the directrix? Y equals 3/4. Yes, it's a horizontal line, and yes, if you write x equals 3/4, you get it wrong, because x equals 3/4 is a vertical line. Because the directrix, now remind me, is the directrix inside or outside? It is outside. So once we determined that it was opening down, I knew that the directrix had to be above. And the focus had to be below because I had to go inside. So the reason why I don't sit there and say, oh, we should memorize all this stuff about focus and directrix and axis and blah, 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 blah. Because I need you to just understand. I mean, yeah, there's some certain things like what is P and where do you see it on the graph? Where is 4P, that focal width? Where do you see it on the graph? And if you understand the directrix is outside and the focus is inside, then the graph really becomes kind of important. Okay? Otherwise, you're going to be asking me questions like this. Well, how did you know that the focus was down? How did you know the directrix was up? Well, and I understand why you ask those questions in the beginning. That's why it's so important to graph it. And for those of you that are going to try to do some of the things you did on the last test and not actually draw out the graph, well, it's going to really hurt because you won't know where things are. And you'll just be making up random stuff. Yes, Mr. The line, just like we drew a line and a point at the beginning, and then made our own parabola. So find an equation in standard form for the parabola whose directrix is the line x equals 2 and whose focus is the point -2, 0. What should we do with that information? Graph it. Thank you very much. Whoops. Distances are always positive. So if you're talking about y is 4p, not negative.
I like why isn't the directrix is
Okay, don't memorize. Don't memorize. Look at the picture. Now that's why I try to stay away from that. Look at the picture. If you had to, the directrix was outside. Do you see that we had to go above the x-axis? So that's why it has to be positive 3/4. Okay, that's why the picture is extremely important. Okay, so we've got -2, 0 for the focus. What's my directrix? What's the center? None. What's the vertex? The vertex is 0, 0. For you football fans, that's half the distance to the goal. Has to be halfway in between, folks. Okay. Which way does this open? Has to be halfway between the focus and the directrix. It opens to the left. Now, folks, I'm just drawing a very crude sketch because that's not the point of this question. I do need to know that it opens left. I do need to know where the vertex is. I do need to be able to calculate. Does anybody know what P is? 2. Yeah, you can see right here it's 2. You could also count over here and see that it's 2. How about? Because the focus has to be inside and the directrix has to be, it has to go away from the directrix because the directrix is never contained inside of a parabola. It has to go completely away from it. Does that make sense? Okay, what is 4p? I'm going to say 8, isn't it? Right? If 1p is 2, then 4p is 8. Just multiply them by 4. Okay, now we were going the other direction. We had 4p, and we were going the other direction. That's why we divided. We had to go from 4p to 1p. That's why we divided. But now we're looking at the picture. We can see what p is. Then we use it to find 4p. In fact, I know my graph is wrong. How do I know that it should be, oops, 1, 2, oh, this is terrible. 1, 2, 3, 4, 1, 2, 3, 4. How do I know that it should be more like this red one? How do I know that my blue one was wrong and my red one is more likely? Because the distance, the focal width, has to be 8. It has to be 4 above and 4 below. And that's how I know my blue one was really bad. No, you don't need to change it. I need you to understand. But yeah, they're not asking me to really sketch it. Okay? So, let's see here. We want the y minus something squared equals something times x minus something. Okay, ask your question, Ms. Coop.
The red line's the focal width, right?
The red what? Like my hash marks on my x-axis or y-axis? Oh, that's the focal width. That's 4p. My 8 unit 4p. Okay. Can you help me fill in any of the spaces? 8 here in front. I do agree with you there. However, there is one thing that we need to consider. Is it positive 8 or negative 8? It is a negative 8 because it goes left. That's it's an important thing because yes, we use 4p, but you need to understand that it's a decision you have to make based on the picture. And if you don't draw the picture, you won't know. Right, sir? Stay with me. Okay, now. What else should we fill in here? 0, 0. So that's why, folks, we can simplify this and make it a whole lot easier. If you, because the vertex is 0, 0. Okay. If you write the one that it's right here at the top, it's technically correct. There's nothing wrong with it. Might get laughed out of parties, but it's technically correct.
Can you explain why it's negative?
Because it's opening left. Negative.
Does it only open left or right?
We know because we started with a directrix over here and a focus over there. There's absolutely no way that could open up or down. Ms. Johnson was asking me about that earlier, and you have to know that that opens left because the directrix cannot be contained Nothing of the directrix can hit that parabola. So if I went up, I'd be crossing that directrix. If I went down, I'd be crossing. If I went right, I'd be crossing. It has to go away from. That's why I keep asking, is the directrix inside or outside? It would open to the right, and then, of course, according to what you just suggested, that means that on my graph, I would have a directrix over here and a focus over here, and it would go this way. Right or up is positive? Yes. And it matches your common sense. Right or up, positive. Left or down, negative. Correct. If it's a y equals directrix, that means it's horizontal. So it either is going to open down or up. You're right. Yeah. Okay. Example 3. Find the standard form of the equation of the parabola with vertex 3, 4 and focus 5, 4. Okay. What are we going to do with that information? Graph it. Thank you very much. 1, 2, 3. 1, 2, 3, 4. Here's my vertex. Then I got my focus at 5, 4. Everybody in the room should know which way this opens. I've got 1 vote for right. You are correct because the focus has to be inside. It does open to the right. Okay, so now where's the directrix? Just curious. If the distance here, which we call P, is 2, then I would step back 2 units to here for my directrix. Okay, what is that equation of that directrix? X equals 1. X equals 1. Wait, what? Okay, about what? Okay. What's 4p? 8. That's true. All right, now we need to write our equation. What's getting squared? Is it the y or the x? The y. So, what goes inside the parentheses? X minus 3, good, and y? Y minus what? 4. What's going here? Positive 8. That's true because it's opening to the right. To the right. To the right. All right. Any quick question before we go to lunch on this? Yes. No, they will not always be the same. That just happened to be in that example. Okay, good point. I'll make that point next period to make sure they don't think that. You're right. That's a good point. All right.